question 1, you're asked to graph y is equal to 3 to the x on the same scale as y is equal to negative 3 to the power of x. Now, first thing you should note is the graph of the function y is equal to a to the power of x cuts the axis y-intercept at 0, 1 and also passes through the point 1, a. Now, in the second case, I should say, what's going to happen is instead of a graph hooking upwards like so, and 1, a, everything is going to be reversed around the axis. So in other words, you're going to have a reflection. So 0, negative 1, and 1, negative a. So that reflects around the x-axis. First thing you've got to do in a problem like this, just to confirm the y-intercept, and clearly that's going to be at 0, 1. There's no x-intercept. There is a horizontal asymptote at x is equal to 0. I may as well do this guy at the same time. So common to both. Now, a second point, as it doesn't cut the axis, we'll put in when x is equal to 1. And in this instance, y in this case is going to equal to 3 or 0, 3. And in this case, y is equal to negative 3 or 0, negative 3. We can then sketch those graphs on the same axis. Both of them are going to have as their domain the real, and both of them are going to have as the range from 0, one to positive infinity, and the other one from negative infinity through to 0. So hooking up like so. Label that second point and label the graph as we've got the two together. So you can see my two graphs there. In the first case, domain, x is an element of real. The range, clearly this doesn't go below 0, so between 0, positive infinity. And we say from negative infinity through to 0. Moving on to 1b, you've clearly got a graph of the form y is equal to a, b to the x, plus 0, or y is equal to a, b to the x. Now the first thing you should note is that's going to be negative because we've had a reflection in the y-axis, so negative x. So I'll run with that generic form. Using the y-intercept, and that's when x is equal to 0, y is equal to 1. Therefore, y is equal to 1, which is equivalent to the a. So in this case, a is equal to 1. When x is equal to 1, negative 1, sorry, y is equal to 3. So in this case, 3 is equal to b to the negative 1. So therefore, b is equal to 3. So we therefore have the graph y is equal to 3 to the minus x. So remember, we're dealing with the generic function y is equal to a, b the x plus k. When we have a negative there, it flips it around, or reflects it, sorry, around the y-axis. The k raises the asymptote, or lowers the asymptote, and the a dilates. I should also put down the domain and the range in this instance. Domain in this case, x is an element of real numbers, and in this instance, we go from 0 through to positive infinity.